So welcome students. In this video, let us look at the topic of incenter and incircle of a triangle. So if you take ABC as a triangle, a circle which touches all the three sides of a triangle is called the incircle of the triangle ABC. Incircle touches all the sides of a triangle. That means the sides of a triangle are tangents to incircle. The sides are tangents to incircle. So that's the meaning of the incircle of a triangle. It touches all the three sides, or all the three sides will be tangents to this circle. Now, the center of this circle is called the incircle or incenter of this triangle. Now, what are the properties of this incenter? So, this incenter is usually denoted by I. Now, as you can see, if the points where the incircle touches, the three sides are P, Q and R. Let this be the points of contact. Now, if I join IQ, do you see that this angle has to be 90 degrees? Why? Because the angle between the tangent and the radius at the point of contact is 90 degrees. So if I draw a perpendicular, or if I join IN, the point of contact, this angle will also be equal to 90 degrees, and this angle will also be equal to 90 degrees. And all these three sides will be equal to the radius of incircle smaller. So all the lengths of perpendicular are equal. That means incenter is a point whose lengths of perpendicular to all the three sides are equal. Or incenter is equidistant from sides of a triangle. Circumcenter is equidistant from the vertices of a triangle. Incenter is equidistant from the sides of the triangle. So now, how do I get the incenter? Incenter is the point of intersection of angular bisectors. Angular bisectors of angles A, B and C. This can be very easily proved because if you join BI, so if you take these two triangles, one angle is 90 degrees, right? These two triangles have one angle equal to 90 degrees. The hypotenuse is common for these two triangles, and one of the side is same for these two triangles, both are R. And this triangle is congruent to this triangle, hence this angle has to be equal to this angle. Hence this has to be B by 2 and this has to be B by 2. That means the line joining the vertex with incenter has to be the angular bisector. Similarly, if I join this, here also we have C by 2 and C by 2. And if you join A to I, that will also be the angle bisector. So I is nothing but the point of intersection of angular bisectors of a triangle. So this will also be the angle bisector. And one more thing which you need to understand is this BI and IQ need not be collinear. This IQ is the perpendicular from I to side AC. This BI is the angle bisector. Angle bisector need not be always perpendicular to AC. So if you join the angle bisector, if you extend it, this need not follow the direction of IP. So let this be, so PQR, let this be S. So if you extend AI, it might cut the opposite side at another point other than P. So you should not confuse this, it should be this as equal to this. These two need not be equal. So once you have this basic understanding of incenter and incircle, so there are some special properties which you need to understand about this incenter and incircle. So let me write it one by one. So the first point which you need to understand is the concyclic property. So the point A the point I, and the foot of the perpendiculars R and Q. So these 4 points will always be concyclic. So A, Q, I, R. So these 4 points will be concyclic, because if I draw a circle with AI as diameter, it will pass through R and Q, because both these angles are 90 degrees. So the sum of opposite angles is 180, hence these are concyclic. Next, B, P, I, R. These 4 points are also concyclic, and Q, C, P, I. Q, C, P, I, Q, C, P, I. These 4 points are all concyclic. So AI, A, Q, I, R, B, P, I, R, C, Q, I, P are all concyclic points. So I hope you have understood why this is happening, because the sum of the opposite angles is equal to 180 degrees. So the second property which you need to understand about angle bisectors is the angle bisector theorem. So this theorem says that if ABC is a triangle and if AD is the angle bisector of angle A, then the ratio of BD by DC will be equal to AB by AC. The angle bisector divides the opposite side in the ratio of adjacent sides. BD by DC is equal to AB by AC. Similarly, if you have the next angle bisector, if you have the second angle bisector, again the ratio in which that bisector divides the opposite side is equal to the ratio of the adjacent sides. So on. So how do we prove this theorem? Why is this theorem holding? So this theorem is called angle bisector theorem, which you have already derived in your lower classes. So to prove this theorem, we use a theorem called basic proportionality theorem. So I hope you remember what basic proportionality theorem is, which states that if you have a triangle and if you have a line which is parallel to one of the base, so if you have a triangle ABC, if DE is parallel to BC, then AD by DB is equal to AE by AC. So that is called the basic proportionality theorem. And using that theorem, we'll try to prove the angle bisector theorem. So let ABC be the triangle and AD be the angle bisector. Now the construction that we do is, we draw a line from C parallel to AD to meet BA extended at the point E. Now according to basic proportionality theorem, these two are parallel, hence BD by DC is equal to BA by AE. So BD by DC is equal to BA by AE. Now what you need to prove is BD by DC is equal to BA by AC. You have BA by AE. So if you can prove that AC and AE are same, then this theorem will be proved. So now if you carefully observe this construction in triangle AEC, so these two are parallel sides, these two are parallel lines, and if you consider BE as the transversal, so this A by 2 is equal to this angle, because these two are alternate angles, and this A by 2 is equal to this angle, which is A by 2, because these two angles are corresponding angles. So these two angles are alternate angles, these two angles are corresponding angles, but these two are A by 2 and A by 2, hence these two angles are equal. Hence AE is equal to AC. AE is equal to AC, and once A is equal to AC, this implies BD by DC is equal to AB by AC. So this is a very standard theorem for angle bisectors, and this is called angle bisector theorem. So if you take angle bisector AD, BD by DC is equal to the ratio of sides on the same sides. That is BD, the same side is AB. So DC's side have AC on the side. So BD by DC is equal to AB by AC. So once you have this, can you find the length of BD and the length of DC? So obviously BC is A, BC is equal to A, and BD is nothing but this ratio. This is C and this is B. So the ratio is C is to B. So out of B plus C parts is BD. So BD is equal to C by B plus C times BC. That is CA by B plus C. So BD is equal to C by B plus C times this side, and DC is equal to B by B plus C times this total side, B by B plus C times A. So DC is equal to BA by B plus C, BD is equal to CA by B plus C. So in the same way, you can create the equations for the other angle bisectors also. So this is the second property of angle bisectors. So now let us go for the third property.